drawing the impedance diagram, no, dapat ito siya represent as an equivalent pi na circuit. Okay? And miss na ako number 2. The magnetizing reactances of the transformers are negligible. Actually, it's number 2 within is here for an impedance diagram. No? Pareho ni, include yan si magnetizing reactance or circuit. So, kung impedance diagram, usually naagin mo yun. So, 2 may sometimes be a special case. Okay, number 5. I know this is a lot to take in, no, pero familiarize lang ka with how it's connected. Number 5, the loads are assumed to be passive and are represented by a series branch of resistance reactance. Okay, so for example, wala tayo load matong load is motor. Okay, bakit we have another load here? So it's represented by a series impedance, no? And of course, it's shunted, no? Dili ka pwede mag-connect sa imong load as series sa motor ha. Dili ka pwede. And of course, motors are also loads as well. It's a tawag naman this is a static na load. Okay? So yan naman. Of course, it's not rotating, di ba? And when you say it's a static load, so may example, ana. Let's say, for example, kung sa balay lang, kanang inyong mga loads, no? Kung i-analyze mo sa inyong distribution operator, tinakian nga analysis, kasagaran na lang buhaton kay ilang nila ang inyong consumption. So, i-represent lang mo as one load. Dili na katun. Mag-consider pa sila as washing machine, so operating time, dili rin na, no? That's just a total connected load. Okay? So, this is for a static load. Let's say, you have a load of like process load. Kasagaran na magkakit, yung mga motors. Basta mga static loads, no nga, walay rotating parts. No? Di ba, ang motor, yung mga lang sa pusat ang load niya, di ba? If you have a line lang na load on the motor, kaya siya kayo nung makusgarong tuyo. Di ba? Kung bugat mo ang load sa imong motor, di ba? Kusog biya na yung torque, so meaning ba, sa utako nga power. So that's why, medyo fluctuate ang imong motor load. For static load, constant lang siya mag-load. Let's say, 40 plus J60 MVA. So, para siya, na siya kasi ng loads. Okay. Next, no? Motor loads. Wala dito. Ang motor loads, they are represented by their back EMF. No? Remember, no? Back EMF ito ang tawag sa motors. Di ba, ang motors, guys, take in sila o voltage. Di ba di ba siya mag-generate voltage? Di ba sa generator, need lang yun mo i-drive yung prime mover. No? Tapos sa imong terminal kaya, generated voltage. Pero sa motor, no? Baliktad siya. Meaning, supplyan niya mo siya. No? Hindi siya mag-generate. No? Hindi siya mag-generate yung motor. Mag-drive siya. So, ang imong connect sa terminal is another load. Okay? Wala with machines. Okay. So it's represented by its back EMF. Dili na siya terminal voltage ha. Back EMF is here. Okay? And then, of course, the equivalent motor resistance and inductance or reactance. And lastly, no, when we are analyzing mga power systems, we assume them to be balanced. Okay? Okay. If unbalanced, meaning you have to represent it as 3 sequences. Okay? Kaya kung unbalanced na siya, meaning ang current flowing in phase A, phase B, and phase C, nalain na, di ba? So, figure siya, no? I-analyze. So, if ato siya i-represent no, as a power system, ato i-represent a power system for ang analysis of some no, na mga methods, we'll mention that later on. So, ato siya i-represent dapat as a balance no, na system. Okay? And of course, grounding circuit is not included, no? Diba, transformer or a generator usually grounded yun na. No? But in this case, wala na siya grounding. Wala yung grounding circuit. May grounding circuit, diba? Unless, kung kinin yung pasabot, that's just a reference bus. No? Pero, dito na siya grounding na circuit. Okay? Kaya grounding na circuit, dito na siya ground na host, diba? Especially for power system na elements, no? Dili na siya directly connected to ground. Sometimes, ano nila, i-connect na siya with a reactor. So, reactor, mura na siya, o i-represent na natin siya as an impedance, either an impedance or an reactance or an inductance. Okay? So, wala na siya grounding circuit na. Okay? So, mga na siya, atong usual rules for impedance diagrams. Okay? So, questions? May questions with this? Sige, wala. Pagkita. Pagkita sa mga questions. Okay na kayo ni Good. Pagkita pa ng pandemic. Okay. So, let's say, we want to model this one as a impedance. Equivalent impedance diagram. Okay. What do you call this one, gani? This is your bus, no? So this is bus 1 and that's bus 2. So around bus 1, it's sabay connected. Generator 1, it's generator 1 and generator 2 and load A, no? And also the primary side of your transformer. Okay? So ang itong generator dapat iyaha generated EMF o ang imuhang series resistance of reactance. So, mga ni. Buwan lang, no? Buwan ng iba. But that's E sub 1, no? Or the generated EMF, resistance, reactance. No? Of course, same with 2. The generated EMF, resistance, reactance. O, pareho ani. Di ba kung sa grounding circuit, it's a resistance. Kini kay inductance, no? Nakita ba ka grounding circuit? Wala. Okay? So wala natin i-include ang grounding circuit. Okay, load A. It's represented as a static load man na siya. So, series impedance na, no? Resistance of reactance. And around or along bus A or bus 1 rather, connected si primary side. Ini, mo rin siya, di ba? Kanina rin na load or kanina rin na connection. No? Kaya di ba? Ano na sila? No? Connected ito. Okay? Pareho ni. No? Why grounded din? Wala may grounding circuit. Okay? Then, the low voltage and the high voltage element, or side rather. And of course, it's magnetizing circuit. No? Connected to the transformer 1 na. And then through transformer 1 high voltage side or secondary side is the transmission line. No? Wala na nakita dira, no? But normally, ako kay tama na ako diri o indicator lang ba transmission line siya. Right. Long na rectangle. Okay, but ako ba textbook, no? Ayaw mo kayo kaya basta magtuwal mo ba ang connection na siya. Dili man mo make sense, di ba? Mag-transform, i-connect sa transformer 1 to transformer 2 niya. For the sake of what? Step down, step up niya, step down na boss. Di ba? Sa power system, especially with power delivery, ito pa i-connect transmission line, no? Kaya deliver ang power. Dili man natin makonect ang transformers nga by themselves lang para to connect or to deliver power. It's connected through a transmission line. Okay. And then it's represented as an equivalent pi na circuit. Of course, no, transformer 2, same, di ba? Y and delta. So you can see anything there, no, that symbolizes either whether it's Y or delta. No? So, marag na single representation mo yun. And then, around bus 2, the connected elements are the secondary of your transformer 2, is 1, and generator 3, is 1. No, yung generator of resistance and inductance or reactance. And then load B, inductance and resistance. Pwede bali-bali na sila. Okay? So, lang. But the question is, what do we do to label these things? So, ano natin pag-label na sila? So, actually, lisod din siya, no? Actually, ang equivalent impedance diagram, medyo struggle siya i-analyze. Diba? Kung mag-analyze ka na, though, pwede yun, magkuhan ka, let's just say, nodal analysis or unsa pa na. Pero, tingnan mo masensayon, no? Diba? Kung mag-mesh ka, mayroon sa mesh 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 ka-meshes. So, that's 10 equations. No? 10 unknowns. So, ano yung pag-solve? Mano-mano or using your calculus. Huwag kami tayo computer. Somehow, bit of a hassle. But, gini ang exact niya na representation. No? Gini ang pinaka-proper. Pero, in our analysis, especially with load flow and fault analysis, atong gamiton kay ang reactance ng diagram. Okay? So what is a reactance diagram? So it's basically just an impedance diagram, pero what can you see? What can you see on the diagram? Walay? Say wala. Walay? Well, resistance, di ba? Nano kayo from the word itself, reactance diagram. So meaning reactances of every element lang. Now what happened with the transformer? Na-represent na siya as one reactance. No? Dili na primary, secondary, o magnetizing circuit. Dili na yung anak. Okay? Of course, the line, the other transformer, and our motor loads. No? So wala na resistance. Para kayo, neglecting the effective resistance of generator armature, transformer winding resistance. So, meaning, ang primary, secondary winding na resistance of resistance, okay, i-neglect, no? And then the transformer is modeled as one reactance. No? Yeah, of course, nawagtan na ang shunt element sa ito ang transmission line. Okay? I-neglect siya. No? Ang magnetizing circuit sa transformer, wala po. Okay? So this is an example of a reactance diagram, as well as this one, no? So, anong cell? Ano cell? Si ES, EC, and EB are connected to
Bus
0. Yung bus 0 is, sama, this is the ground. Nung rara siya gibali. Rara siya gibali. Okay? And of course, they are really effective na mga armature reactances. This is a reactance diagram. Okay, so depending on your system, no? It's a very simple system na kanang straightforward lang yun, ana to ana. You would normally expect an announced reactance diagram. But what if the system looks like this? So it's G1, and it's connected to some bus, and this bus is connected by some transmission line, then connected to another, it's a G2, no? Yeah, along this bus, na-avoid connection of another bus. Let's say that one. So we can see, this is still, this can be still represented as a reactance diagram. Pwede ka pala siya ng reactance diagram. So, depende lang gitna. Sometimes, transformer diha. Okay? So, so Ini siya ko din na siya ma-represent as a reactance diagram. Pero medyo tricky siya gamay. No? Pero paano problema kay as long as you know kung saan na bus or kung saan na element na connect to that bus. Okay? Dapat makasabot ka kaon or asa siya na-connect. Mauragid na, asa na-connect. Okay? But, nag-mention ko ganina the labels. No? Tininanin yung label, tininanin yung diagram. So how did we get that label? Sa unit, ano nila? What do you think are their units? Do you think they have units? Do you think they have units? Okay?
Well,
Per unit na sila.
per unit.
Per unit. Okay? So, dito na sila ohms. No? There are per unit. Okay? So, just a quick review, of course, those formula. No? Just don't forget, no, CB is equal to BB squared over SB. And of course, the change of phase, no? Conversion to new phase. Na, very important, no? The way you memorize this, siguro, depende ninyo ba, when I was in undergrad reviewing, ako din ang nauna na V1 over V2 with ang E square. And then baliktad na ang usa. Ano rin yun? Kamu, bahala. Saan na ninyo pag-memorize. No? Okay? But, nag-derive naman na, di ba, sa ito ang klase. Okay. Okay. Kini, wala lang i-load ha, kaya wala lang ito sa diagram. So just one that. Ini, let's have an example. Draw the per unit reactance diagram for power system shown below. Neglect resistance ito isa na. A base of 100 MVA, 230 kVA, 50 ohms na. The ratings are as follows. This one is for the generator, the transformer 1, the line, no? J50 ohms, T2. One and motor. Okay. Just neglect that. Wala na lang. Wala sense. Okay. So, what do we do? What do you think should we do?
Convert.
I-convert. Diba? Convert na ito new base because nag-ano ang tao?
Base sa
Okay. So how do we do that? Okay, before magtrabaho na, it says here to 20 kilovolts and 50 ohms line. So meaning, kailangan to 20 kilovolts, at sama na siya. Base voltage sa asa. Transmission line, no? So, at every base, at every section sa inyong power system, pag-usap-usap na ang inyong voltage base. How? Ano ba usap na siya? Because of the transformers. Di ba? Ang voltage dili na siya pareho dito. Of course, klaro kayo doon, no? Step up mo or either step down mo. So, meaning, ang voltage across that zone, let's say this is zone 1, and across this zone, let's say that's zone 2, and across this zone, they have different na base voltage. Pero, sir, what about this one? That base, MVA or base apparent power, is the same all throughout the system. Ang mausabra kay ang imuhang base voltage. So meaning, at zone 2, the base voltage is what?
220.
220 kilovolts. Okay? Okay. So what is the base voltage for zone 1? What do you think?
20.
So, na to? Ano tatanaw sa transformer? Transformer 1 is what? 40 MVA, 30 kW, 220 kV. No? So if we transform this voltage, pass through man siya either T1 or T2. So what is now our VB1? So our VB1 is just 220 times the
Waiting.
rating, no name transformer. So what do you think is the numerator?
Ang answer. Waiting 1.
Sa rating sa, ayun sa ikuan, numerator,
33.
33. No?
220
220. Would it make sense if 220 times 220 over 33? Dili, di ba? Dako kayo na, 220 squared all over 33. Mutuo ba mo nga 220 squared over 33 ang voltage dira? Dako ka na nga voltage. So that would not make sense, no? So careful mo with transforming the voltage. So meaning VB1 is equal to
33.
33 volts. Okay. Sige. How about VB3? Sige, give me the answer.
3.
Meron na kayo, di ba? What is the VB3, zone 3? What's the base voltage at zone 3?
And 11.
Hmm?
Base voltage.
Ilan?
Ay,
Sa ba nga transformer?
Baan ka
Step,
step down.
step down. So, mag-expect ka ng voltage, mas gamay ba? Ano eh?
Ah.
So, kailangan na nila eh?
11.
11. No, kay 220 times 220 over 11 over 220. Okay? Sir, what is sir? 230 na VB2. Out. Oh, yeah, well, the same thing you would do. So meaning 230 times 33 over 220. No? Okay, kasi nalalaman na usap na ang base voltage. No? Kini timing lang kay ni match na. Okay? Sige, let's continue. So, of course, that this one would make sense, no? Because ang generator na 25 kV, di ko lang yung 30 kV, so okay ra. Diba? Mura na good na imuhang appliances, let's say, no charger. Usually, mga charger sa Japan, sa old na. No, diba? 120 ra gyud na, or 110. Remember ko, nakagubagin ko DVD player sa unang nagigas sa Japan. Kaya kung isaksak tayo, wala itong adapter ba? So, ang isaksak, butos niya. No, so, 110 man, yung isaksak 220. No? So, karon di ba, may 110 slash 220, may nana, di ba, sigara. Pwede na siya isaksak 220 to 240 nga outlet. Okay? Wala siya, no? Let's continue. So we have VB1 for zone 1, VB2 for zone 2, VB3 for zone 3. So saan na ito siya para ma-represent na ito ang reactance diagram. Sige, ako sang i-draw. Saan pag-draw sa reactance diagram, ani? Sa unang button. From left.
Source
Voltage ha?
generator.
No? So let's say that's EG1. And then our reactance ha? Reactance na to. Okay? Susunod. Transformer. Okay? By the way, sir, wala lagi na ikuhan doon, sir. Nag-get breaker. Ang proper get circuit breaker at every point, no? Or every point of connection with power system. Kaya wala lang. And ikaw, gawin ninyo, dili na nalilimutan ang breaker. Okay? Sunod. Transmission line, no? Sunod.
Transformer. Ay, transformer.
And then connected parallel to that is
Motor load.
motor load, no? Which is the representation of the reactance and its back EMF. Now let's call that EB1. Okay. So this one is our reference node or bus. It's our reference bus. Sometimes minus na din ang reference bus ra good. Ba, hindi ko na kwento lang po. Sila reference. among each other. Okay. Pero sa labels, ano eh? So how do we do that?
Convert.
Convert ta, di ba? So ang ganito, sa ito i-convert? Ang?
Yes.
Yes, pero sa siya ng quantity ang reactance.
Reactance.
No, or ang impedance. But this one is reactance diagram. So reactance na ito kita din. Okay, so what is our XG PU XG new na lang na kanya, assume na per unit na sa di ba? Kasi may buong mo, sir, sasa ka per unit na. Di ba? Nag-mention ko sa lecture na the percentage is just the per unit. Okay? This is XG. Let's say XG new. So how do you do that?
Base.
Generator sa ta.
XG all. XGP all.
So this is
0.2.
0.2. Pero, reactance pa na. So, pwede raw dyan, good, dili ka magbutang sa J. Mas may na ng J. Okay? But pwede raw dyan, na yung bang solutions mo, din nabot nga ng J. Ako kapag nga ako J, kaya proper man. J, 0.2 times, sa mani. It's 2 over
S1.
Power.
S1.
New base over the
Old
base.
base.
Yeah, from the lecture, ang old base is the what?
Old
The
base kay rating.
Rating sa imuhang element. So, generator naman kita now. So, what is S2 by the way? 100.
100.
100 ang BA. Hindi na lang pagbutang ka times 10 to the power of 6 kay.
Over
Asa grama?
40.
Over
40.
40.
40.
Times B base 1 over, or B base old rather, over B base new.
To 20 over 25.
So, dire, pila man eh?
To 25 over
Old, no?
25.
Old is 25 over
to 20.
20.
To 20 kilovolts.
To 20, sure mo?
34.5 na.
Ayun, sa'yo.
33.
So, 30 ang gamit din ako. 33.
33.
Ano kayo?
Ang base.
Ato na.
This is?
Ah,
Pila man eh?
30.
J.
Benito.
Second point. Ako gigamit sa lecture kay inserting a base, maraming lahi na akong results. Yan ay 0 point. Naman. 0.29. What's the unit?
Per unit.
Per unit. Okay.
0.29.
So there is J 0.29.
09.
No, assume that it's yun lang bulag PO ang taas na. So that's in per unit. Okay, how about the voltage? What is the per unit voltage?
Okay.
BPU.
BP.
Kuya man, sa ganito ang per unit, the first formula for per unit.
Kuan.
Actual over base.
Base.
So what is our actual? 25 over,
33.
the base is?
33.
Now always look at the base at every zone. Nung di ka pwede mag-good-good ito ang base, no? At every zone. Ano lang i-zone? So this is 0.76
76.
per unit.
Per unit.
Okay? Since that's assumed to be the reference, that's normally 0.76 angle 0. Okay. How about our transformer one? Sige. You give me now the new.
Transformer 1.
Dili ko magsulat sa formula. Sige, you try.
Transformer 1.
Okay. Ako lang sa dere. Kini, the problem with this is that the primary side is connected to zone 1. The primary 2 is connected to zone 2. Sorry, the secondary side rather. Secondary side is connected to zone 2. So, sir, ang saan gamitin na? So actually, it really won't matter. Okay? Pero, you have to make sure you know where the side na you're referring to is connected. So let's just say, sir, ginahan ko sa primary side ko mo refer to. So meaning, ang imong base o imong new base ana kay magtanaw ka sa zone 1, no? If mag-refer ka to secondary side, of course, ang imong new base voltage rather is zone 2. Okay? So careful tayo because this is a usual na mistake no by students. No? Nag-refer sila sa primary side pero ang ilang base voltage kay secondary. So unusual kayo, mahimo na noon nga 33/220 squared. Ano ba? So that would not make sense. Okay? So what is XT1 new? This is J 0.15,
15.
no? 0.5. By the way, tawagan niya is the leakage reactance, no? Leakage reactance. Kining double, no? Still the reactance, but later na lang ito i-discuss and ika-fold na, no? Because sa generator na ay double current, not current na may anak, napig na no? So sa generator na siya, but that will be used for fault analysis pa. Okay. So this is J 0.5 times 100 over 50.
Dili 15, sir. Transmission, sir. 1.15.
Ay, 0.15. Oh, 0.5. Sorry. 0.5. 0.15. Times
5 times
100 over. What's the rating? 40. Space old. B base old. What is B base old?
30.
Asa man refer?
Sa zone 1.
Sa primary side?
Primary.
So 33 over
220.
23.
So kung secondary side, it would not, still the same, di ba? No? Kung primary, secondary side, tagutan na ba? Di ba, secondary side is 220, niya asan siya connected? Zone 2. So more again, 20 over 20. So that's still 1. This is equal to pila? J
0.36.
36.
38.
75.
75.
Let's say 38.
So,
Ayan, 75 lang. By the way, when you're solving, kailangan ba, ang decimation na ito kay up to 4 decimal places. Okay? Kaya sometimes, naay ubang ratings na close kayo sila, pero lang ikot ang solution. Like for example, 34.5 niya, kung sa akin, gamit yung 34. Hindi ka, kung mag-in mo na siya isolve, tapos maroon ko, kung na siya magkapareho na sa ako ang answer key. Kaya hindi magigamit, kaya lahat hindi. No? So let's keep the decimation to 4. Okay, so kailangan at least 75 lang sa. Next, connected to transformer, from transformer 1 to the other side is
zone.
zone 2 din na. Zone 2, pero sa kanya din
Transmission
line.
Okay. Kanang J50, saan na siya? That's the X actual sa imuha transmission line. That's actually the X actual. Okay? So how do we get the X PU? Yeah. Actual over base. Pero unsa man ang base impedance or base reactance? Impedance lang yun, unsa man ang base impedance? Nakabata? Wala, di ba? Pero solve na to. Oh. So what is Z base? Z base is equal to B squared over
Power.
B, no?
Base.
Pero sa maning base dire, sa maning B dire, sa mga base. Zone 2, di ba?
Zone 2.
This is PP 2. So meaning this is equal to
The 20 squared.
Actually, pwede naman siya 20 squared. Pero let's just make it proper. Kasi sometimes, ang uban, masayop ilang yun. Napol, ang V-base kay 100 kVA, I'm sorry, ang SB kay 100 kVA, tapos ilang 20 squared over 100. Pero 100 kVA is not equal to 100 kVA kaya. Diba? So, okay, for solutions of bases, make sure na lang na kailangan you times 3 or 6, I don't know. And then over SB, which is 100 to the power of 6. And times 10 to the power of 6.
6.
This is equal to
484.
484. What is the unit?
Ohms.
Ohms. Okay, correct. Now take note ohms na ha. So meaning our, let's just say that it's CPU. No, actually, X naman dyan na siya. Pero Z lang yapon, general na Z. So CPU is equal to, so transmission line is equal to X niya nga actual, no, sa timuhang transmission line over saan?
Base.
Base, no, which is the
Z base.
okay. So this is equal to J50 over
484.
44. This is equal to bila? J 0.103 unit.
Per unit.
Per unit. Of course, no? Klaro kayo, di ba? Makancel ang ohm. Ba, J50 ohms
Oh,
na.
ohms.
J50 ohms na ha, dili na siya per unit. Kasi pag dinaibutan tira ang ohms, kung na juga J50 per unit, hindi na ma-ohm. J50 ohms na usually. Wala na sa label. So this is G1 here, this is P1, this is transmission line, P2, this is motor. So this is J 0.0375. The transmission line is J
0.103.
And then, of course, sige, ikaw mo daw solve sa transformer 2. What is transformer 2 na XT2 new? Ano sa answer?
62 new. 0.15.
11.
0.15 daw.
This is J. Wala.
0.15.
Di ba 0.5? Di ba 100 over 50? 100 over 30?
1 over 30.
0.5 J.
J.
0.5.
Nag-agree ang tanan sa answer? Everyone get the same answer?
Sa akin, dito.
Dito, transformer 2.
Calculate.
11. 11 is again 20 times 11 over 20.
Ano ka dito ang base voltage? Either, kamu bala, primary, secondary. Huwag mag-vote ninyo. Wala. 0.5?
Oh,
Did everyone get the same
0.5.
thing? 0.5?
Yes, 0.5.
I will test you on 0.5. Okay, how about the motor? Okay, you do the motor. I-neglect ang load ha. J 0.6. Sakto. 0.6. Very nice. Okay, how about its per unit voltage? Sa akin ang per unit voltage. Sila? Bakit natunggan? 1.
9 kapin.
Ha? 9?
0.9 ang kapin sa niya.
11.
Really? Kaya, what's naman ang
1 or then?
V actual?
11.
11.
One.
What is the V base at zone 3?
11.
So,
1.
1.
Per unit. Balance.
Okay. So, ano ra? Di ba? Okay, question. A question regarding this one? Okay. So, wala siya, no? Kung i-try ninyo og 230 ang base, voltage at zone 2, kamo na wala na. Synthesize na. Try ninyo ang 230 kV, bawat 230 kV ang zone 2. Ano yung reasons mo? So, I will give you, there are lang basic word, no? This is an exit ticket. You can try to solve yourself. Ilang yung exit ticket, di ba? Ilang yun. Kung i-pause na. Para makaw mo. Makaw mo.
Ito, papel ko din.
Nagalit ko. Sige, kita sa mas maayos kung ano hindi mo tanaw sa answer key. Just try to answer on your own. Ay kanang kamura. Hindi na mo mag-topic. Kita tayo to ano. Okay. So kana practice mo with this one ha kay for the rest of the entire semi-final term. So you will go back to you'll go back to MATLAB, no? You will code again, and things na you will be coding will be power flow. Power flow na algorithms. So ito na power flow di ay. Ito ganyan akong ipakita, di ba? But as a reading assignment, that's chapter 6, no? I hope you get into at least no 6.9, not 6.29, 6.9. Okay, so siguro if mag-browse mo with chapter 6, for sure no ma-overwhelm you because this is a lot of mathematics. No? It's linear algebra. No, there's matrix and all, but dili na tama ka ng old conventional way of solving because that's not practical, no, for you to solve. Just isuro lang yun. Dili practical na mag-solve mo. What if your system is 5 buses? So solve mo dito mo 5x5 na matrix. Kapoy na. No, kapoy na magiging 3x3. Mata lang magiging ko. So you will be just looking at, dapat kung gyapon nga naamoy ka ng knowledge, no, with the math behind it. Kaya di man mo kakuha sa pseudocode, no, or sa algorithm if you don't know the math. Okay? So, you will look at chapter 6, no, power flows. So, what's man yung ang power flow? You would normally see that in usual textbooks. They didn't want ang power flow, no, sa usual textbooks. Okay? And there's somehow a good amount of math here. No? Hindi, basi ma-overwhelm mo ba? Patay, ang matrix, nanay calculus. No? Pero, OA naman na siya. Good. That's just the Jacobian. You're just getting the partial derivatives, etc., etc. Okay? So, no? The power flow problem starts at 6.4. No, you have to know what is a swing bus, what is a load bus, what is a voltage controlled bus. Okay? So, things like that. No? Ini, mo siya ang pasabot. Diba? It's an example of a somehow a bigger power system. No? Pero, ang gamit din sa kining nga libro kanang Glover, yung gigamit na software is Our World. Our World. Ano ba? So, maybe medyo siya kanang wala na ko nag-introduce ani sa inyo ha. So, you will go back to what is kanang acquainted with you, which is MATLAB. No? And also, I'd like you to download as well ETAP, no? ETAP. I will give you the link ng daan. So, ang ETAP is a power system design, no, software. So, sa mga power system design software. So, dito mo maka-design sa imong power system, di ba? And then you can also not only design power systems, but you can also conduct analysis. Okay? Sa ETAP, ang power flow, no, kung power flow analysis ka, one click ra na. Basta na lang kay system. One click, magawas dayon ang katong pila current coming in, pila sa voltage at this bus, kung sa PQ coming in and coming out. No? So things like that, no? One click ra. Pero I want you to code, no? Because I want you to understand how does that algorithm works. So there are mainly three algorithms of power flow. Sa man, Gauss-Seidel, no? Newton-Raphson, for sure, no, you're very familiar with Newton-Raphson. No? You've had that in numerical. Ang Newton-Raphson sa power flow, very similar lang yun sa pag-numerical ninyo. And also, the fast decoupled power flow. Kanang tulo. So, maybe ang pag-itanaw kung i-group ba mo by 3 groups within the class ba? Okay, para di na redundant, lalo ka magpapiyakay ng code. So, maybe I will divide into 3 groups. No? So, pero dili kaya matulungan tayo yung groupings pag itong prelim and midterm. I will divide you in 3 groups just for this term, semi-final lang. No? Kung kinsa ang Newton-Raphson, kinsa ang Gauss-Seidel, kinsa ang fast decoupled power flow. But, balik ta sa uli na, taas-taas ang kukuhaan. BSA 4-9. You can use your CTU email to access this one. If dili, request lang mo access, tapos reply ako sa email. Okay. So, balik ka no, let's see, naabot ko dito. Where you try this one. Kabaw ko lang ay answer, no? But 1,000. Oops, wait. Draw the per unit circuit.